Hi, my name is David, and I try to play guitar. I'm not very good, as you can tell. One day, I saw a video of blues great Joe Bonamassa getting very technical about his guitar amplifiers. For a guitar player, that guy really knows his stuff about amps. He inspired me to learn more. But to really understand guitar amps, you need to take them apart and put them back together. I watched hundreds of videos. I read all kinds of books. From Craigslist and eBay, I bought a used soldering iron, some old voltmeters, an ancient oscilloscope, and other test gear. Eventually, I built an entire electronics lab. Now, I guess I'm sort of an amp mechanic. I fix other electronics too, and this is my journey. I figured I'd share so others can learn too. I hope you like it, and just as a disclaimer, be sure to consult an expert before working with electricity. Hey everybody, Dave the Amp Mechanic coming to you from my amp lab in Boston, Massachusetts. And today I'm going to make a neat little gizmo that's going to help me to get down to the final repairs that I have to make on this Crate Vintage Club 30 amplifier that's sitting behind me. Now, when this first came in from the guy who fixes my guitars, he said, go ahead, mess around with it, learn on it, make some mistakes, don't worry about it. I have another one, so I really don't need this one. And use it to basically train yourself up on how to fix amplifiers. Now, this amp isn't the best amp to learn on. It's a combination of tube and solid state technology, and solid state's not really a great place to start when you're learning to fix amplifiers and old tube radios. But I gave it a shot, and actually I've got it pretty much near done. I still have a few remaining problems with it, and one of those problems is one that I'm going to solve in the next 24 hours. But I had to make this neat little gizmo in order to help me get it working, and I'll show you what I did. Now, when you study the schematic for an amplifier, which I strongly recommend you do before fixing one, it will sometimes give you some clues on how to test it. For example, the schematic for this Vintage Club 30 amp tells you some very specific information about how to test this amplifier, where the different test points are in the circuit, what voltages, both AC and DC, you should be observing with the clean circuit on, with the dirty circuit on. And it also tells you a little bit about how to set up the circuit. For example, it tells you what the volume controls should be set at, the bass, the treble, etc. It also tells you what the reverb should be set at. And what's most important is it tells you what sort of impedance it should experience in different parts of the circuit. So for example, the amplifier normally has an 8 ohm speaker. You can't really test the circuit unless you have that load on the amplifier. In fact, you should never test or run any amplifier without a load, either the speaker itself or some sort of resistor that emulates that load of the speaker. In my case, I've got an 8 ohm 100 watt resistor mounted to an aluminum heat sink because they get pretty hot when you're running these tests, and it's emulating the load of the actual speaker. Now, why would I do something like that? Well, primarily because you don't really want to listen to the signal that's going through the circuit if you have a signal generator or something like that while you're working on it. It can be a little bit annoying. So you just want to kind of run the circuit, have the load on there, not the actual speaker, and then you can actually kind of do some diagnostics with your various instruments like your digital multimeter or your oscilloscope. Now, one thing that I noticed with the schematic on this circuit was that it specified exactly what load should be on the reverb circuit. In other words, the reverb tank that comes with the amp should be of a certain resistance. It says to make sure that you have 150 ohms of resistance on your reverb circuit. Now, when Al, the guy who fixes my guitars, brought this amplifier over to me, he just brought the chassis. He didn't bring the cabinet. And what's in the cabinet? Well, usually the reverb tank, which provides that sort of resistance to the reverb circuit, is mounted to the bottom of the cabinet. So I said, Al, you got to bring the cabinet over. I need access to the reverb tank so I can stick it on the circuit and get it up to spec in terms of the resistance that the reverb circuit should be showing. That way, when I do my tests with my digital multimeter and my oscilloscope, I've got it all set up right. It turns out if you don't have the right resistances and you don't have the right settings built into your tests, you're going to see some out-of-spec results anyway. So if you want to verify that you're getting the right results at the right test points, you need to follow what the spec and the schematic says. So he brings the the cabinet over to me, and I fish around in the bottom and I dig out the reverb tank, and it was this one right here, an Accutronics 4EB 3C1B reverb tank. This is definitely a replacement reverb tank. It's not the one that came stock in the 1990s class Crate Vintage Club 30. It looks new. It doesn't even look nearly as old as the rest of the amp. And so I sent a note to him and I said, hey Al, is this the original reverb tank? It doesn't look like it. And he said, oh no, I replaced it. And then I thought, uh-oh, we've got a little bit of a problem here, because what if the resistance of this reverb tank is different from what the amp originally called for? So I looked this up online, the 4EB 3C1B, and sure enough, this particular reverb tank provides 600 ohms of resistance, not 150. So I was like, wow, okay, we can't even use this reverb tank in order to do the tests. What do I do? Well, what I'm going to do is I'm going to use my resistor substitution box, and I'm going to put it in place of the reverb tank to provide 150 ohms of resistance on the circuit there. Okay, but what I also need to do is I need to make this neat little gizmo to connect the resistor box to what was normally the inbound connection for the reverb tank. So right here, this red RCA jack with the red plastic bushing around it is the one, that's the input side of the reverb tank. And so what I needed to do is make some sort of fitting so that I could connect my Sencore resistor box to this connection, to the wire that normally went on this connection. So it's basically the male side of the RCA jack going into here. So I need a female RCA jack to the resistor box. So I'm going to show you what I did in order to fabricate that little connector, because I'm sure I'm going to need this again when I do tests further on down the line. Now one other point, I could have avoided this and just traced the wire going back into the chassis and found the connections where the actual wire going into the chassis connected to the circuit, and just connected my resistor box with some alligator clips to those connections. But hey, I like the convenience of being able to just keep the wires out of the way and put the resistor box somewhere else as opposed to right on top of the circuit. And so I'm making this little wire gizmo hookup thing, and I'm going to show you how I did it. Now just real quick, before I get into making the gizmo, here are the wires that are connected to the reverb tank. This one's the inbound wire, it goes to the inbound side of the reverb tank, and this is the outbound. So I could have just as easily connected my resistor box up to these two connections in the circuit board and put the resistance on that way. I could have run a wire right out of the resistance box and just connected right up here. Pretty easy to do. But I don't know in the future what sort of amplifiers I'm going to encounter where I have to do something like the same thing. Like maybe these connectors will be underneath the circuit board or very difficult to get to. So much easier if I can just figure out a way to take the RCA wire here, right, like that, and connect it up to something that provides the specified resistance, which in this case, as I said before, is 150 ohms. So let's go ahead and build that little doohickey. Okay, so here are the raw materials of my little gizmo. Nothing fancy here. The first thing I have is a piece of RCA cabling that I clipped off another adapter that I had purchased at Radio Shack a long time ago. And I always save these things because I never know when I'm going to need to make something interesting out of them. And so what we've got here is the female side of the RCA jack, and I've stripped the wires down here. So, you know, I've got these two leads like that, and this will be what plugs into the wire coming out of the chassis that normally would plug into the input side of the reverb tank. So it's essentially going to emulate the reverb tank, and I can put 150 ohms of resistance on this. Now the other thing I need is a large piece of heat shrink tubing, not that large, that fits over this wire here because I'm going to seal it all up and protect it. And then I need smaller pieces of heat shrink that are going to go over each of these pieces of wire. So I have two pieces of that go over each of these to really cover them up. And each of these will have one of these alligator clips soldered onto it, right? And these alligator clips are what will clip onto the leads that come out of the resistor box. So let's go ahead and I'm going to start to put that together, and then you'll see how it looks once we have it finished. Okay, so the first thing I'm going to do is I'm going to take the bigger piece of the heat shrink, and I'm just going to put it over the whole thing like that. We'll just leave it like that for now because later we're going to pull it up and push it in, right? And then we want to take each one of these guys and we want to put them over the individual wires. But that's too big, so we have to cut it down to size. Because remember, we're going to kind of fit it to these alligator clips. So I'm thinking maybe about half the size here. So I'm just going to take my snips, snip it down. And in fact, I don't even need this one. I can just use these two here, right? And it's just providing a little extra protection. Once we kind of get that hooked up, it doesn't need to provide a lot. In fact, that's still too big, so I'm going to kind of take it down a little bit more. There we go. And then it would be something like that. Like I want to pull it down to here, and then once I solder that up, I'll pull it up a little bit, and I'll heat shrink that guy. And then I'm going to pull this one over the two of them, because they'll both be sort of the same, in a way that there are no exposed wires. Okay, so let me get working on that. Okay, let's go ahead and put a little solder there. Okay, nice, very nice. And then we'll do the other one. I don't know if you can see that, nice bead of solder. Okay. Now, one of the things that I always do when I'm soldering is the smoke cannot be very healthy for you to have coming up in your face. So I have my fan going here, and so you probably hear the noise in the background, my old vintage GE fan. And it basically, as I solder it, it just blows the smoke right off out of my face. That way there's no way I'm breathing all of this smoke in. All right, I'm going to solder up there. The fan is blowing stuff all over my surface here. I'm going to solder up this other one, and then we'll come back and we'll do the heat shrink. Okay, so my fan is off, and I've got these two leads soldered on very nicely, right? And the next thing I want to do is I just want to move the heat shrink up as close as I can to the two leads like that. So move them up, move it up like that. And let's go ahead and fire up my heat gun. And the other heat shrink is way down here, so I don't melt that one yet. So I'm just gonna Okay. Let's see. Hopefully I did that in the camera. I wasn't really looking. And the next thing I'll do is I'm going to put the rubber guys on here, because I want to make sure I don't want to push this up so far that I can't get those on. This is basically going to go something like that, right? But these rubber insulators are going to keep the clips from actually making any serious contact with each other. So I'm going to put the black one on the what was the shield. Previously was the shield. So I'm going to slip that on here, and the red one will go on this other one here. Here's the red one, and then we'll move this up. So let me get those on. I'm not gonna. It takes a little wrestling with this to get them on right, and then once I have them on, we'll put the heat shrink up and we'll see the final product. All right, there we have our leads, and you can see I'm leaving the. I'm actually putting a little force on the bottom of the insulators here, just the jackets, just to keep them. Basically, the whole alligator clip covered, because when we hook up the other alligator clip on the side of the resistance box, it's going to actually go inside there. So this way they make no contact with each other. So let's go ahead and so now we've got these guys all set up, and that's the finished doohickey right there, right? And so what we can do is we can get the resistance box out, and we can give it a test and see how it works. You know, hopefully it does the trick. So let's see what happens. Okay, so first things first here. Here's my Sencore substitutor box. It does resistors, it does capacitors and rectifiers, electrolytic capacitors. So it's a little nice piece of vintage gear that I picked up along the way. I found it at a house where the gentleman who had passed away, and they were doing an estate sale. He was a TV repair guy, and so I think I got this for like $5, and it's actually a nice little vintage piece of gear. It does need some rejuvenating, because as you can see right here, I'm pointing at 100 ohms of resistance, and over here it says 108. Now the next one up is 180. And that's a little tricky because I'm supposed to provide 150 ohms of resistance. Let's see what we get there. It's a little out, so it's 187. I can probably use one of these two, right? Either one will be in the neighborhood. It doesn't have to be exact. The point is that the 600 ohms of the existing reverb tank is way too high. I just want to get in the ballpark. Anyway, this is just proving that the box is working. It's a little out of spec. So the next thing to do is connect, we'll put the light on, whoops. We'll make sure we get the backlight on this guy working properly. The next thing to do is put the doohickey I made on there just to make sure it tests out okay. So 1 second on that. Okay, so what do we have here? We have my little doohickey that I've made, my little harness or whatever you want to call it. It's the resistor box leads are connected to the alligator leads right here, right? So I've got red connected to red, black connected to black. Not that it really matters when you're measuring resistance. And now I'm going to take this guy here who goes into the digital multimeter, and I'll put him on there. I got to kind of hold him on there like that on the shielded part, and let's go ahead and try that and see what happens. And there you go, we're getting the exact same resistance. So that works now. And let's do it one more time so you can see it with the backlight on. I don't know if it went off in the middle. There we go. Pretty much the same as what we saw before. So now I can, I know that this is going to do the job. I'll take these off here. And the other thing I can do with this, if I really want to, is if I need to put some resistance on there and it's not, I don't like the resistance that the resistor box is doing, I can always take a resistor like that and just kind of, you know, clip it on like that, and I get the same exact effect. I can just clip these two guys like that. Just kind of. So I don't even know what these guys are. These are 10 watt 100 ohm resistors. Yeah, I use these for discharging capacitors. I have a couple of these laying around. So anyway, there you go. I've got my handy dandy adapter for adapting any kind of resistance to an amplifier circuit where the reverb normally plugs into, and all set with this nice female RCA jack. So pretty easy to make, and I look forward to using this once I get it connected up to the amp to put the amp closer to spec in terms of the test points and the expected resistance that we're supposed to load into the circuit to get the desired results. So I probably messed up as usual. If I made any mistakes or you have any questions, please feel free to drop those questions into the comments below. And if I made any mistakes that I know about, I'll put them in the show notes. So thanks, and we'll see you at the next video. Bye.